Show on the road here. All right, now we're recording. Great. So we're happy to have Cian here talking about distribution costs. Alessandra, you're happy to take questions in the chat if need be?
Yes, I can do that.
Perfect. Okay, but otherwise, we treat this like a regular seminar, so feel free to just unmute yourself and jump in with a question. If you'd like to ask your questions in the chat room, you can do that as well. We'll have time at the end for further questions and comments, and we'll just kind of leave the stream open. Okay, you have an hour. Cian, go ahead and take it away.
Okay, thanks a lot, Kim. Thanks a lot to all of the organizers for giving us the opportunity to present. So this is joint work with Alessandra, and of course the standard disclaimer, IMF disclaimer applies. So our starting point is that developing countries have particularly low productivity in many distribution sectors of the economy, and there's a lot of different ways to measure this. One, for example, is that if you look at the World Bank's Logistics Performance Index, that's particularly low for low-income countries relative to more advanced economies. And at the same time as having kind of these low productivity measures, they also tend to have a lot of high regulatory barriers. So India, for example, which is the country we'll be talking about today, has the second highest entry barriers in distribution services among countries covered by the OECD. And one of the main reasons that policymakers get really kind of concerned about this is concerns that poor distribution can then affect other sectors, and in particular might be a bottleneck for manufacturing firms distributing their goods. And as economists, there's a lot of different approaches that we've taken to kind of quantifying how important distribution and international trade costs really are. So there's sort of a more macro-based approach, which looks at input-output matrices and sector-level data to measure these kind of the macro significance of this. But this tends to use kind of a lot more aggregated data and misses all the firm-level heterogeneity. And oftentimes there's a lot of kind of imputed stuff that goes into this. The trade approach tends to rely a bit more on indirectly inferring the magnitude of trade costs from flows of goods across space, or looking at spatial price gaps as well, for example. And then you've got empirical studies that really look at the kind of impacts of individual specific, for example, infrastructure projects. So you get kind of great measurement of the impact of one particular project, but then you're missing slightly the macro external validity. So in this paper, we're going to do something a little bit different. We're going to directly look at some pretty cool plant level data on distribution expenditures for Indian manufacturing plants, and then use that to actually come up with a quantitative approach to analyzing how important distribution is for manufacturing firms. So let me kind of directly jump into what we think is a pretty new and direct measure of distribution costs. We're going to be looking at Indian manufacturing plants from 1993 to 2013. And what's unique about this data is that plants are reporting their annual expenditures on what's called outward distribution expenses. I'm going to talk quite a bit about what's included in this, but for now, think about things like transport, freight, shipping fees, transit insurance, packing fees. That's the kind of stuff that they're actually reporting what they spend on it. Now there's three main findings that we see when we look at the data. So for one, distribution costs are large. So they're 3.2% of aggregate sales. And while you might think, okay, that 3% seems kind of low, that's half as large as labor costs. So these are an expense for firms on the same order of magnitude as how much they actually spend on labor. Secondly, large plants spend disproportionately more on distribution compared to smaller plants. So plants in the top decile, the size distribution, spend 3 times more than plants in the bottom decile as a share of their sales. And then finally, we find in the data that over time, the aggregate distribution share has really substantially declined. And in particular, declined by about a third from 2000 to 2010. So from around 3.8% of aggregate sales down to 2.5 over this time period. Now, when you see kind of a big cost component of firms falling over time, you might think, well, this might signify that distribution became cheaper and there might be aggregate gains from this. But in order to answer that properly, we really need a model to do that. So that's what we do. We're going to present a fairly simple model with 2 sectors, a distribution sector and a manufacturing sector, in which there's going to be heterogeneous manufacturing firms. And our story is going to be kind of very familiar and simple. So manufacturing firms are going to be shipping their goods across space, and they're going to face both fixed and variable costs that increase with distance. And high productivity firms are going to be shipping their products further than low productivity firms, and therefore they're going to have a higher distribution share because they're reaching more distant markets. Now, what's nice though is that we're going to be able to quantify this model using the new plant level data from 2000 to 2010. And in particular, we're going to actually be able to match the moments that we have on the magnitude of distribution costs, as well as the systematic heterogeneity that we document. And in addition to this, we're going to present some new estimates of interstate trade in India that we're also going to use to calibrate the model. And I'll talk about those in more detail later on. And what we're able to do with the model then is do counterfactuals. So in particular, one of the main exercises we're going to do is evaluate, we're going to indirectly infer the change in kind of the productivity of the distribution sector and of fixed and variable costs of trade from the model, and evaluate how much reduction in these costs from 2000 to 2010 increased welfare. And what we find is that these implied really large gains, so 41% welfare gains over this 10-year period.
Hey, Cian,
and
just before we jump into it real quick, like you talked about fixed and variable costs of distribution. How are you going to be thinking about inventories here that are, or the costs involved in inventories, right? Like, you know, in some sense, if I have to hold larger inventories for stuff that's in transit, or before I pay these fixed costs, those inventory carrying costs, are you going to have them part of distribution, or are you going to have them part of just, you know, other financial costs of the firm?
Yeah, so that's a good point. So they're not going to be direct. So we're not going to incorporate them specifically. The measure of distribution costs we have does not include the kind of holding cost for inventories. We are going to be using data on kind of the amount of interstate trade to kind of infer the extent to which fixed costs matter. So to some extent, inventory holding costs might kind of be indirectly inferred from that, but it's not going to be explicitly a part of the model, and we're not going to be measuring it. Although, you know, we do have data on inventories, so it is something in principle we could kind of.
Yeah, I mean, those just systematically vary with, you know, the destinations and the source of inputs. Okay, thanks.
Yeah, no, that's a nice point. Thanks. So briefly, kind of before I jump into the data, you know, we're probably most closely related to sort of the macro development literature on the importance of intersectoral linkages and how these really matter for economic development. Now, except what we're really contributing there is, while we're focusing only on two main sectors, distribution and manufacturing, we're really digging into the micro data as opposed to just looking at sector level data, and showing that actually that micro heterogeneity really matters for a lot of questions of interest, because actually it's specifically larger firms in the Indian economy that are more exposed to the kind of low productivity in the distribution sector. Of course, there's a huge literature on international and intranational trade that this paper is related to. Here we're just kind of mentioning some of the papers that have specifically focused on India. And really what's new in this paper is that we're going to have this direct measure of distribution costs and a way of kind of pinning down internal trade barriers through these kind of variable distribution expenses. And finally, you know, there's an important kind of literature which has shown that distortions that kind of are correlated with firm productivity and increase with firm size can actually be really important for explaining productivity differences across countries and reducing aggregate productivity. And what we have here is we have one specific kind of example of a tax or kind of a cost that is correlated with firm size, and therefore kind of fits this idea of distortions that kind of can disproportionately affect large and productive firms. Okay, so I'm happy to take questions, of course, at any time. You can ask them in the chat, but I'm happy to take them in person also. So I'll jump into the data. So we're going to be working with kind of the commonly used Indian Annual Survey of Industries. This is a survey of formal Indian manufacturing plants. And we're going to be looking at data from 1993 to 2013. So this is a representative sample of all formal plants with at least 10 workers with random sampling. And we have a lot of the standard variables that you get in all of these data sets, like output and capital and labor. But what's really unique about this, and we haven't seen elsewhere, is that what's reported is a pretty unique measure of what's called outward distribution costs. And I've just kind of copied in a snippet from the ASI manual here, which is kind of describing what's in this. And it's outward freight, rebates, commissions, transit insurance of goods sold, and packing fees. And now when I say this is unique, like for example, a lot of other data sets that we've worked with, even for example, the US Annual Survey of Manufacturers, they just don't report this. So we don't really actually have good measures of how big these costs might be for firms. And that's what's pretty appealing about this data. Now, what you'll notice when you look at these things, they really look like variable costs, right? They look like things which increase as you ship more stuff. And instead, they're kind of excluding what we often think about as components of fixed costs. So, you know, the difficulty in finding distributors, paying advertising fees in your locations, that kind of stuff. Now, throughout the paper, throughout the presentation, I'll be talking a lot about the distribution share. And that's going to be, I'll be normalizing distribution costs as a share of sales. And that's because we think, you know, firms are distributing goods. So this seems to be the appropriate kind of scaling factor to think about how much this matters.
Hey, Cian, can I ask a question?
Yes, of course.
So what happens if I sell the good, like if I'm a farmer and I sell the good to a wholesaler or to a retailer, and those guys have to rent a store, they have to, yeah, that's like a huge gap, right? Like it's like 50% the share, the gap between producer prices and retail prices for consumer goods.
Yeah, yeah. So where this would appear is, for example, a lot of like these kind of resellers. So we're looking at you know, manufacturing plants. So we're looking at already formal manufacturers, and yeah, they might be going through a lot of resellers in foreign markets, and a lot of resellers charge a commission, right? So they take a share of what's going on, and so a chunk of that will appear in the kind of commission component of this aggregate distribution expenses. Now, you know, but you're making a broader point that like, we're not making the statement that these measures of distribution costs cover the totality of kind of transport costs in the economy. But what they do kind of focus in on is sort of how much these are sort of directly affecting kind of manufacturing firms. You know, how much are they actually spending themselves? And
it's what they spend. Because if you look at manufacturing or goods, it's the gap, I would say, is closer to 50%, at least for the US, for goods, for consumer goods. So that's it's mostly retail. Like think about like a pair of shoes that you buy. It's mostly like retail value. It's like what they pay for very little, and they add a markup. They have to rent the store. I mean, that's huge. So you're not going to measure that.
No, so I guess we're not going to have like a thinking about the retail sector markup in a sense, and so but we're going to be still coming up with some pretty big numbers just from this, right? So what we're measuring here is going to have pretty big implications, but you know, this, as you said, is arguably kind of understating sort of the bigger picture of like the totality of how these costs matter. But yeah, I mean, let me kind of show you just even. So this kind of leads me nicely onto sort of what our first fact is that like we think these costs are actually pretty big, right? Even though they're not including everything you might want. In particular, they're sort of 3.2% of aggregate manufacturing sales. That's an average over time. But you need to remember that these are kind of being incurred in principle at every different stage of the supply chain, right? So firms are kind of selling inputs to each other, and that's a lot of what's going on here, right? They're not selling directly to wholesalers, but they're actually selling to each other in the intermediate input network. And so kind of another way of thinking about how the order of magnitude here is that these are 10% of aggregate manufacturing value added. And in contrast, this is about half as large as labor costs, right? Which are 6% of sales, or nearly 20% of manufacturing value added. And you know, the reason there's such a big gap between these kind of sales shares and value added shares is simply that in Indian manufacturing, the intermediate share is huge. Now, what's kind of nice is that for the years 1993 to 1997, the ASI actually reports how big these different subcomponents are. And in particular, so the transport cost component, so that's basically, you know, what the manual says is this is going to include shipping fees, freight, transit insurance, and packing fees. That's about half of this. Another big component is commissions, which is 18%, and also rebates, which again is kind of another way in which manufacturers might kind of provide, you know, might be paying for kind of higher quality distribution in distant markets. So, you know, the second big fact that jumps out from the data, though, is that the distribution share is really heterogeneous across firms, right? So it's not only big, but what this figure shows is we're simply plotting as this a bin scatter plot of the plant level distribution share of sales against plant output. And so this is kind of conditioning on industry by year fixed effects. It looks identical if we kind of also have industry by year by state fixed effects. So this isn't sort of being driven by geographical variation or anything like that. But you can see that the difference across the size distribution is enormous. So for the smallest decile of plants, on average, their distribution share of sales is around 1%, but it's more like 3.5% for plants in the largest decile, so 3 times larger. And not only that, but every subcomponent that I just described previously is also increasing in plant size. So this isn't simply driven by kind of one or two of these different subcomponents being particularly important. So, these costs are large, they're heterogeneous, but, we're looking from 1993 to 2013 in India, and, we know that there were huge economic changes that were going on over this time period. So it's kind of natural to ask, well, how are these distribution costs changing over time? And so what I'm plotting here is just the time series for the aggregate distribution share of sales, which on average is 3.2%. But you can see it really declined sharply from around 2000 to around 2010. That's kind of where the big decline really happened. And it's by about a third, right? So from 3.8 to 2.5%, which is pretty huge. Now, there's different reasons that this could be changing, right? It could be changing because of compositional effects. It could be that the firm size distribution is changing and that's pulling down the aggregate share. Or it could also be that, within a given plant size category, the distribution share is falling. And so that's what we look at here, where we're basically again plotting the bin scatter plot of the plant level distribution share against plant size for an early period around 2000 and a late period around 2010. And there's a few things to note. The first is that for any given level of output, the distribution share is lower in the later period. So this is kind of a within plant size group. It's being driven by within plant size changes. And secondly, it actually declined more for larger plants in particular. So you can see the gap is just sort of increasing the further out you go to the right. And a simple summary statistic to actually capture this trend is just the ratio of the aggregate distribution share of sales to the unweighted average, which fell from around 1.6 in 2010 to around 1.6 in 2000 to 1.4 in 2010. So those are sort of the main facts that we're kind of interested in understanding and explaining and even then quantifying. So, what's our interpretation of this? And I think I'll start with sort of, in particular, the relationship between the distribution share and plant size, which, as I kind of showed you, is steeply increasing. And we have a very kind of standard and maybe familiar explanation, which is that, well, the variable cost of distribution increase the distance. It costs more to send, a unit of stuff 100 miles than it does 10 miles. And larger firms have to sell to more distant customers, right? In order to expand, they have to reach more and more distant markets. And so because their marginal customers further away, they're going to have a higher distribution cost relative to their sales. Now, we don't actually have direct evidence on this for India specifically, because there's not a huge amount of data on this. But for example, Holmes and Stevens show that for the US, this is really the case. So large manufacturers ship their goods a lot further. And there's a mountain of evidence for exporters, maybe starting with Bernard and Jensen, that larger exporters tend to ship further away or to countries where shipping costs are larger. Now, we do consider some of the other major maybe concerns or kind of alternative stories that might be relevant here. And one is simply that this could be due to measurement error, right? So maybe small plants have worse bookkeeping, and that would introduce kind of a systematic bias. But what's kind of nice is that we're able to look at a measure of inward distribution costs as a share of sales. So that's basically how much plants spend on acquiring their material inputs. And we can look at the relationship between that and size. I can actually maybe click on it here. And you can see that that's actually decreasing with plant size in contrast with the outward distribution share of sales. So really, if this was just a question of bookkeeping by differences between large and small plants, really these two things should be going in the same direction, and that's not what we see. It also, it could be driven by, we're concerned that maybe this is to do with profitability declining with firm size, but that's not the case either. If we measure distribution costs as a share of total costs, we can see the exact same relationship. And finally, this is going to be a model of intranational trade. And so we showed that actually, this pattern isn't being driven by foreign exporters, right? So even if we exclude exporters in the data, we still see the same kind of steep relationship between the distribution share and firm size.
So there was some discussion in the chat of So you're not capturing the component of the distribution cost that is paid by the purchaser. And I was just wondering, is there any way to tell whether, that's something that varies systematically with size, and that could, potentially be accounting for this, at least some component of this relationship with size, in the sense that, if I'm big, I do my own shipping, but if I'm small, the buyer, who has more organizational resources, comes and picks up the stuff. I don't know whether that's a reasonable story, but I just don't know whether you have any evidence sort of that would allow us to sort of see that that's not what's going on.
Yeah. So okay. So that's a good. It's a good question. So we do see a slight. If we look at, we can't kind of tell this for example, retailers. We don't observe data on that, but we do observe these kind of what I just mentioned, these inward distribution costs. Now they are decreasing with plant size. You can actually see that a bit there, but the magnitude is a lot smaller than what we see for outward distribution expenses. So, this wouldn't be explaining kind of the threefold increase that we see across the size distribution. So that would be one way, maybe that would be kind of consistent, I think, with what you're saying. That there might be a little bit of that going on, but it doesn't seem to be quantitatively large enough to really explain what we see. But we're interested in, it's a nice idea. If we could find data on kind of nailing that down a bit more, that would be really interesting.
Sorry, related to this, is it possible that actually this would be explaining that suppliers tend to locate close to larger plants? In that sense, the larger the plant is, the closer the upstream suppliers will be to the plant, so the lower will be the distribution cost. So in that sense, can you control, or do you have data on the distance or the mean distance to the suppliers? To the upstream.
Yeah. So unfortunately,
that wouldn't be a measurement error. That actually tends to be a source of agglomeration economies that might be kicking in.
Yeah. So unfortunately, we don't is the short answer. So I think that there's very limited data for India on kind of that sort of information about how where firms are actually shipping, and we don't observe that here. I think there's, for more recent years, there's maybe some kind of new value-added tax data that people have looked at. So maybe there's a way to kind of look at that. But I think, these agglomeration externalities I'm sure are kind of relevant to some extent, but I don't see how that would sort of be explaining kind of the broader pattern that we observe here in the data. But so,
can I have a question? Is there another force that would give rise to this increase in size, that large firms are more productive? They have a lower kind of production marginal cost. So, like, think about the distribution cost doesn't vary much with productivity in production, and that will give you that, right? Because lower cost of production, but the cost of distribution stays the same, so higher distribution share.
So they're all selling like to the same market. Yes. So I guess if let's say the market was the same, and then the distribution share, you had just marginal cost heterogeneity, I guess that would imply that the distribution share of sale would be increasing also. I guess that would be kind of an alternative way of thinking about it. I need to think about that a bit. I think we do know, based on other countries, we do have sort of plenty of evidence that like larger firms do sell to more distant customers though, right? So we think that this is kind of a natural way of capturing this, but I agree, we just don't have the data to really, tease all of these different points apart, unfortunately.
Are you able to distinguish between multinationals and just exporters?
Multinationals and exporters.
The story being that the very productive firms will set up their own distribution chains, and they'll set up a company overseas to sell. So they'll take on more of the distribution costs on their own books. Less productive places will just let somebody buy it there and take on the costs of distributing it overseas. Now, you're not going to, my understanding is from your data, you're not going to be able to really get at who has a bunch of offices all over India versus who just has the one plant. But when you get to the very big guys, you might be able to distinguish between a multinational and just somebody who doesn't have a foreign presence.
I see. So by foreign presence, I mean you mean like in a different state or something, right? Because we're really focusing on like what we can exclude. So I think the typical plants that we're looking at here, are kind of, especially once we exclude exporters, when we still see this kind of strong trend is we're not really looking at like the Amazons, right? Or kind of the Walmarts in the US, where you kind of think about really the marginal, the competitive advantage of these firms is their distribution network, right? I think in India that tends not to be the case as much, especially over this period, because we just simply you don't have those kind of huge national firms.
Well, they're not there's not that many of them, but they're very important economically. So I'm trying to find a way of kind of cutting at this issue with the data you actually have. So if if at that tail you could distinguish between a multinational, there may be like 4 or 5 of them. It may not be that many. But they're going to be economically really important. Your Tatas or whatever. And if this relationship still holds up between those two, then you can take this argument away. If it isn't, then you have some sort of quantification of how important it is.
Yeah, that's a nice idea. I might talk about this more afterwards in the chat if that's okay, because that seems like a potential thing that we could do. Thank you. Yeah. Okay. So I agree that there are definitely more things that we could. Oh, sorry.
Just
one more
real quick, just one more thing. Just I don't know how much you've done with like the export stuff, but I do think you'd want to have some controls for export intensity and exporting, because you definitely see that firms manage their inputs very differently. And part of your story is that, the further you go away, the higher your distribution costs are going to be, right? And so the export intensity is going to be a direct control for the same amount of sales. That the sales are further away. And so it's going to be a really easy way to kind of discipline your model, as opposed to just saying like, hey, this is the 2 types of firms. But really the export intensity and the discrete jump for the same size is going to be really important for your model and making this point, I think.
The export intensity. So for foreign exports, yeah. So I mean, we'd see the same broad. This is kind of when we just drop all the exporters in the data, right? So these are firms then that like have 0 exports, and there is kind of a downward shift in distribution expenses, as maybe you might imagine. But we still see this kind of strong size relationship here. But
I understood that your story was really going to be the bigger firms are selling further away.
Yeah.
And you don't actually have a measure of how far away they're selling, right? But you do have a measure. It's for some guys are exporting, some guys are not exporting, and some guys are doing more.
Right. Yeah.
And so that's going to directly speak to like the strength of your mechanism. So
that's a nice idea.
So anyhow, just a thought. I think you can leverage it in this data quite a bit.
Yeah, definitely. That's a really nice idea. I think that's something we can kind of show how much that differs, and then we can see what we can do with it. Great, thank you for all these are super useful comments. So I really appreciate the thoughts and the engagement. So kind of the last kind of piece of, let's say, the puzzle also that we're sort of interested in is also, why did this aggregate distribution share change so much over time, right? So even let alone the fact that it's big and it seems to vary with firm size, it did change quite a bit. And I think there's actually quite a lot of evidence from existing research as to why this might actually have happened. And in particular, the 2000s were like a huge period of investments into infrastructure projects in India, right? So there's the Golden Quadrilateral that was built, which was a big highway network that linked up the 4 corners of the country, which was then quickly followed by the north-south and east-west corridor, and also rural roads program, which is linking up cities and more rural areas. And not only would you think these things might actually just be reducing kind of the freight costs and the transport costs for firms, but they might also be particularly beneficial for larger firms that are more interested in selling to kind of more distant places to begin with. So not only would they be able to kind of explain a decline in the level of distribution costs, but also that maybe a bit of the flattening of that size relationship. But what's nice about this is also that even anything that affects the price that firms are paying for distribution services will kind of be will also be something which should appear as kind of changing the distribution share over time. And so there's some nice research looking at how service sector reforms, in particular in transportation, kind of which kicked off in the mid-90s during the big wave of liberalization, actually kind of stretched into the 2000s and showed that these did benefit manufacturing plants. So kind of putting this all together, this is the kind of story that we think seems to be relevant here, that like a lot of these sort of reforms and infrastructure projects, our empirical evidence kind of suggests may have had particularly large impacts on kind of larger manufacturing plants. So that's sort of the data. I am conscious of time, so I do sort of want to show you the basic structure of the model and then get to how we're actually going to calibrate it and quantify the model to the data facts that I showed you. So the model setup is going to be fairly kind of standard and quite familiar. So it's basically, think of Melitz plus an Archelaus model in continuous space and without international trade. And to keep things very simple, we're just going to view the economy as a circle where everything's going to be symmetric. And at each point on the circle, there's a continuum of consumers and heterogeneous firms. Now, these firms then are going to be purchasing distribution services from a distribution sector in order to sell to consumers and other firms all around the circle. And so output's going to be used both as a consumption good and as an intermediate input. And that's really important actually to capture the fact that that we have this roundabout production, and so that the share of sales isn't actually a good approximation to kind of the aggregate importance of this cost. Understanding in basic housekeeping, time is discrete, agents are risk neutral, and we've got no discounting. So, starting with kind of just the final good producer, at each point on the circle, there's going to be a final good producer that's going to aggregate varieties available at that location L on the circle. Varieties are going to be heterogeneous in terms of their quality C. And so, higher C means more utility for the consumer from that particular variety, and also means more efficiency in the production of the intermediate good. We've got our standard CS elasticity of substitution sigma. And then the main thing to know is that the set of varieties available at each location L is going to be in the endogenous variable. So this omega L here is endogenous. Now, output then is going to be output YL can either be consumed or used as an intermediate input. So, for simplicity, we don't have kind of a separate aggregation for consumption and for materials. And then at each point on the circle, there's going to be a mass L of workers who are going to inelastically supply labor. So they're kind of maximizing utility subject to their budget constraints. So basically they earn labor income plus their share of the profits, which though in equilibrium are going to end up being zero because of free entry. Now, what are the two sectors these workers can work in? So there's a distribution sector, which we're going to assume is very simple, is perfectly competitive. But what really matters is the TFP of the distribution sector, right? So distribution services are linear in labor. And so one of the key parameters in this model that we're interested in is the kind of the TFP of the distribution sector, or equivalently the price of distribution services. Where things get a bit more interesting is in the manufacturing sector. And we're going to have an endogenous mass J of firms at each point L. And these firms are going to have idiosyncratic quality C, quality C. And so their problem is they're just going to have to choose for each other point on the circle how much of their output they're going to sell at that particular point on the circle. And really all that matters in this model is going to be the distance that you're selling to. So N here is going to range between 0 and 1/2 because we're kind of normalizing the circumference of the circle to 1. Now what we're going to have then is selling to a point at distance N on the circle is going to require both fixed and variable distribution costs. And these are going to be increasing with distance, as I'll show on the next slide. And then just in terms of, again, kind of keeping in terms of the size distribution, we've got an exogenous exit rate delta, and we'll have endogenous entry. So you've got a large potential pool of entrants who pay sunk costs FE before observing their quality. They then enter, and then basically the kind of the entry condition is going to make sure that the kind of fixed cost is equivalent to the sort of the expected profits of the firms. So, okay, so where do these profits come from?
Cian, just why do you need dynamics in this? There wasn't anything I saw that said I needed to model that, but or did I miss something?
I mean, they're not like relevant for these dynamics aren't particularly relevant for the model. So they're not like it's not going to be a dimension that's interesting. It's just to kind of keep things stationary and yeah.
Thanks.
Cool. So then the manufacturing firm's problem is, so they're going to be producing goods. You can think of kind of the actual good itself is going to be produced using both materials and labor. And then, but to sell these goods to a market that's a distance n away, they're going to have to produce 1 plus epsilon n units of distribution services. So a couple of things to note here. So these distribution costs are scaling in kind of the amount of stuff that you're selling, not ad valorem. Kind of thought that was sort of an appealing feature in a way in terms of thinking about how these distribution costs are incurred. And then epsilon is going to be the kind of the second important parameter in the model, which is going to govern how rapidly these costs increase with distance. So when epsilon's very high, really, you know, the difference between selling locally and selling far away is enormous. While if epsilon is 0, basically, you know, it costs exactly the same to sell 10 miles away as it does to 100 miles away. And this epsilon then is really going to help us understand kind of how the distribution share varies with size. Now, because the firm's kind of production is going to be constant returns to scale in output, actually the problem is going to be separable for every separate market. And so we can kind of write down the profit maximization problem for a firm of productivity C selling to a given market N, and then we're going to kind of be able to consider each of these separately. And so firms are going to be facing a downward sloping demand curve, and they have to hire production labor and purchase material inputs from other firms. And then we've got a simple Cobb-Douglas aggregation whereby that turns into output. And then they're going to have to produce, they're going to have to purchase distribution services at a price PD, which they take as given. And again, as I kind of highlighted before, epsilon here is really going to govern how quickly these distribution, the distribution services required increase with distance. And finally, and kind of, you know, we also have fixed costs F, which are also going to vary based on the distance that the firm is selling to. So, you know, as you can see here, F is increasing in N. And so, you know, in particular, once you kind of reach, once N kind of tends towards a half, these fixed costs go to infinity. So we don't really have in the model any firms that are serving the entire circle. So, you know, in the sense that, you know, no firm in India is going to be serving the entire country and reaching every single market available. There's a point at which you sort of keep things kind of constrained. And then beta, which is going to be the third parameter that's, you know, related to distribution services in the model, is going to kind of govern how quickly the fixed cost of distribution increase with distance also. So beta, epsilon, and then, you know, AD or PD are going to be the three key things that to keep in mind. Now, you know, in the end, this problem is very simple to solve because we can simply consider that, you know, we can solve for the threshold distance, which is the furthest market to which a firm is going to sell, based on where its profits are basically going to be 0. And so N star is going to be the longest distance to which a firm with productivity or quality C sells. And so its total profits are simply the integral from 0 to N star of its profits in every market. So that's kind of the overview of the firm problem. How does this link then to kind of the distribution share? Well, so what's nice is that this yields like a very simple and kind of intuitive expression for the distribution share of sales in any given market. So the distribution costs relative to sales are a function of, well, so first of all, you'll notice here, so C, by the way, is just kind of a cost term, which includes aggregate costs. So the distribution share is independent of firm quality C, conditional on the market it sells to. So all firms that service a given market are going to have the same distribution share. But the distribution share is going to be increasing in distance N. So the further away you sell, the higher your distribution share in that market. And of course, you know, the distribution share here is going to be decreasing in epsilon and in 80, or sorry, increasing in epsilon and decreasing in the productivity of the distribution sector. And so really what's going on in the model then simply is that all, you know, conditional on the market you sell to, all firms have the same distribution share, but larger firms are just selling to further and further markets. And that's what explains the fact that the distribution share is increasing in size. And so there's a very simple case where we can kind of show this, where if you just set beta equal to 0, then N star, remember, which is the sort of the furthest distance that a firm is going to sell to as a function of its quality C. Well, this N star is going to be increasing in psi. So higher psi means you sell to a more distant market. And again, this is going to, epsilon and AD are going to matter here. So a higher epsilon is going to kind of make it more expensive to serve different distant markets. So you're going to sell more locally, and a higher AD is going to make distribution services cheaper and allow you to more easily cover the fixed costs and therefore serve more distant markets also. So that's kind of the firm view. And then maybe one last piece to kind of cover sort of the broad mechanics of the model before we go into the calibration is, well, what happens if epsilon's falling, right? So if epsilon falls, it basically becomes cheaper to ship goods longer distances. Now in partial equilibrium, you've got two effects. There's an extensive margin. So all firms are going to sell to more markets because it's cheaper to do so. So basically N star is going to fall conditional on C. And then there's an intensive margin effect where all firms are going to sell more in each market, just because this is like a reduction in marginal costs. However, in general equilibrium, you're going to get that the wage is going to increase due to kind of higher labor demand, both in the production sector and in the distribution sector. And this is going to increase the minimum threshold quality C star, which is the lowest quality that any operating firm can remain profitable at. And so when epsilon falls, what you're going to get is high quality firms expand, low quality firms exit, kind of a standard Mellet style logic. Okay, so
just one maybe stupid question. It was a bit quick for me, but how does the epsilon affect things differently from this AD, the productivity in the distribution sector?
Yeah, absolutely. So so epsilon, I don't know if you can see the mouse here. So epsilon is going to particularly matter for the cost of serving more markets that are further away. So in terms of like selling, if you're selling the market where you're actually located, epsilon doesn't matter at all, right? All that matters is the price of distribution services. But epsilon is going to make it comparatively more expensive to sell, like all the way across India, right? Relative to kind of selling just locally. So you can think about, we kind of sometimes think about epsilon as being like, is there a kind of a highway network, for example, that links up two very far away cities, is going to make it much cheaper to kind of sell these kind of very long distances, but it's not going to affect the price you pay in your local market, right? Because it's not relevant for that. But I'll show you then in the model how really epsilon and AD are going to be separately identified by the moments that we're going to calibrate them to, and we'll have a little identification figure which maybe will help with that also. Okay, so calibrating the model then is sort of the next step. And we're going to calibrate the model to match basically three kind of broad sets of moments. So the first are sort of the new data moments we have on distribution costs. So we're going to match the aggregate distribution share, as well as the ratio of the aggregate to the average distribution share. And so the aggregate's going to really pin down AD, the kind of productivity of distribution, while this ratio of aggregate to average is going to help us understand, it's basically kind of the size dependence that we found, and it's going to pin down epsilon. But we're also going to need one extra data moment to help pin down the fixed costs and the rate, and that's going to be the interstate trade share. So we're on the next slide, I'll show you, we've actually digitized new data, and we're kind of putting together some new data on interstate trade in India, which is going to help calibrate the model there. And thirdly, we're going to match some kind of standard firm size distribution moments, because we kind of have rich heterogeneity in firm sizes in the model. So that's something that we can easily pin down. And so then we can use the model to quantify, kind of do a range of counterfactuals and do some sort of accounting exercises, both to understand how important both the level and heterogeneity in distribution costs is, as well as understand, well, okay, this downward trend in the aggregate distribution share, how, is this kind of indicative of falling costs of intranational trade? And if so, how big were the welfare gains from this? And what's kind of nice is we'll be able to separate the contributions of how much epsilon changed, how much beta changed, and how much AD changed. So before I kind of get into the exact calibration, let me just tell you about the new data we put together on interstate trade. So our goal is we needed a measure of some way of tracking how far firms are selling within India. And as we talked a lot about before, we don't really have this at the plant level, so this is kind of tricky. But so our goal was to construct a measure of interstate sales relative to domestic production, and to know in particular how that changed over time. That's going to give us a sense about how trade flows overall actually changed. So what we did is we digitized what's called DGCIS data, which provides data on interstate rail shipments in India over time. And we kind of digitized this for 2 years, 2000 and 2010. And there's 3 main features of this data to keep in mind. The first is that, so it only has rail shipments. It's got no shipments by road. And as I kind of mentioned before, that's pretty important because this was a period in which there was a lot of highway infrastructure that was developed. Secondly, it only provides data on quantities of shipments rather than values, while what we kind of really want is values. And finally, what's interesting is that it actually separates shipments that were for domestic consumption versus shipments for export. So for example, you know, if we'll see separately in the data shipments from to Karnataka for consumption in Karnataka versus shipments to Karnataka that were then exported abroad outside of India. And it's actually this third feature of the data that's going to help us kind of resolve the problems from these first 2 parts. And so we're following the approach from Van Leeuwenhoek, where we're going to make 2, you know, arguably strong assumptions, but they're going to bias quite a lot. So for each product, we assume that the ratio of domestic to exported shipments is similar for rail and for road. And secondly, that there's basically the same quality of goods are exported versus shipped domestically. Now, why is this going to help us so much? Well, what we can measure in our data for each product is the quantity of interstate rail trade that's exported relative to the total quantity of interstate rail trade. Now, that first assumption is going to imply that, well, actually, that's the same thing as the ratio of quantity of rail and road interstate trade that's exported relative to the total quantity of rail and road interstate trade. And the second assumption about quality is going to mean that, well, the ratio of quantities is actually going to be the same as kind of the ratio of values. So what we get then is we have a way of measuring the value of interstate trade exported via rail and road relative to the total value of interstate trade. And so we're going to call this ratio R. And then to get to the final step to get to what we want is if we take the export intensity of that same good, which is just simply aggregate exports relative to domestic production, and we divide that by R, we're actually just going to recover the interstate sales share. So interstate sales are relative to the value of domestic production. So there's a few kind of steps in here. And what we find actually is that this, this interstate trade share increased from 23% in 2000 to 32% in 2010. So pretty substantial increase. Now, before I move on, I'll kind of make 2 comments. So one is that, you know, unfortunately, India doesn't have any better data of which we're aware of interstate trade for this early period of time. So in more recent years, there's kind of some nice data which document pretty high levels of interstate trade. But this is kind of, as far as we're aware, this is the first attempt to sort of measure the extent of interstate trade back in 2000 and over time. And the second is, though, even though the quality of exports and domestic shipments, you know, is probably quite different. I'm sure, you know, there's a lot of evidence that manufacturers export higher quality products than they ship domestically. What really matters for us here is going to be the trend over time. And actually the assumption that the quality gap between exports and domestic shipments is constant over time is much less strict than assuming that there's actually the same level of quality between exports and domestic shipments. And that's really what we kind of are going to, what we really care about in our quantification is going to be this trend or the increase in the interstate trade share. Okay, so that's kind of that's the last data component. What we do then is we're going to calibrate the model to data for 2000. We're going to, you know, make some standard assumptions. So quality C is distributed with the Pareto shape parameter eta. The intermediate input share is 77%, which is what we measure in the data. The exit rate is 8%. And we kind of take that from Peters. And so we're going to have then the rest of the parameters are going to be jointly calibrated. So we've got 5 parameters, 5 moments. And so what we include in the table here is basically each parameter, the moment in the model and in the data. Sorry, the moments that we're going to be hitting in the data, and the moment that it's most kind of closely related to or most identified by. And so the aggregate distribution share is going to identify AD, the ratio of aggregate to average will identify epsilon, and the share of sales across states will identify beta. And we have one last problem here, which is simply we have to identify what a state is in our model, which is a circle. And what we say is that a state is basically a 7% segment of the circle. And that's because that's basically the average GDP share of the typical Indian state. Now, obviously this is all jointly calibrated, but we can kind of show some figures to help with intuition about, identification and how the different parameters are identified. And so what each of these figures is showing then is for each parameter, we're going to start with our baseline calibration. We're going to change that parameter, and that's what we're showing on the x-axis, the kind of how much we change that parameter relative to its baseline value, and then plot the change in the 3 key moments related to distribution. So if I start on the top left, what you see is that if I increase AD, so I'm making distribution more, the distribution sector more productive, I've got a very big decline in the aggregate distribution share, right? It lowers the cost of distribution, so firms are spending less on it. On the other hand, it's not really changing the ratio of the aggregate to the average all that much. And so it's kind of increasing slightly, but it's not really benefiting large firms all that much more than it's benefiting smaller firms, because everyone's benefiting from lower distribution costs. In contrast, if I look at Epsilon, which specifically governs how rapidly distribution costs increase with distance, well, you can see if Epsilon goes up, so that's making distribution more expensive, while the aggregate distribution share goes up, so it's more expensive, firms spend more on it, but the ratio of the aggregate to the average also goes up a lot. And that's because it's making distribution more expensive for firms that were already shipping to very far away markets, and these were the large firms. And so that's kind of what's going to separately identify AD from Epsilon here. And then finally, you can see that in the bottom left, we've got beta. And so an increase in beta, again, is making distribution more expensive, but via fixed costs. But what it does is that actually increases so it's going to lower the aggregate distribution share, because remember, these are fixed costs rather than variable costs. So firms are just exporting less far away. And so they're spending less on distribution overall. But it has a very big impact on the interstate trade share. So it's really narrowing the set of markets to which firms are exporting. And sort of the intuitive way to think about this is that, well, if we see in the data a very high distribution share, that could be either because productivity and distribution is really low, and firms are shipping really close by, but the low productivity is making the price really high, and so we have a high distribution share. But it could also be that actually productivity is super high, the price of distribution is really low, but firms are shipping very far away. And in order to separate those two stories, you need a measure of kind of the total amount of trade going on, and that's what we get with that's how beta is identified. Okay, so what is our first set of counterfactuals? So we're going to do a couple of accounting style exercises to understand how kind of macro important this is. And our first exercise is simply to consider, well, what if we consider like an intranational free trade counterfactual, right? Set AD equal to infinity. So distribution is free except for fixed costs. We still have fixed costs. Well, in that case, the model predicts welfare gains of 47%. So very sizable, and that's kind of just purely captured from the high level of the distribution share. But also accounting for the size dependence is really important, right? So if we go from the initial calibrated value of epsilon down to epsilon equals 0, then we get welfare gains of 17%. So again, this is kind of capturing the fact that, well, if you make distribution the same price for very far away markets as for close by markets, well, then you get these 17% gains because it's kind of allowing firms to ship much further away. But what's also important about the size dependence is that it really amplifies the losses from low productivity in the distribution sector, and can also dampen the gains from improvements in productivity. And the way we look at this is by considering, well, what's the aggregate impact of a decline in the TFP in distribution? So we're going to lower AD by 10%, and we're going to consider how big the welfare impact of that is in our baseline calibration with sort of a high value of epsilon, and in a counterfactual in which epsilon is 0. So the distribution share is the same with firm size. And so the welfare gains are minus 3% versus minus 2%. So the losses are 50% bigger in a model that accurately captures the systematic size heterogeneity than in a model in which you just assumed that all firms have the same distribution share. Now, it's slightly more complicated when we look at kind of increases in firm TFP. But what we find is that, so what we were able to consider is the impact of kind of a change in the Pareto shape parameter, which basically makes it kind of increases the share of sort of very high productive firms. So this obviously leads to kind of big welfare gains. But these gains are smaller when you have a higher value of epsilon. And that's because it's basically, these firms, in order to kind of get bigger, need to sell far away. When epsilon is high, they're more constrained, and that makes it more difficult. So that's sort of kind of the more accounting side. So just to wrap up with our last exercise, what we do is we calibrate then the parameters also to 2010. So what I'm showing here is, again, the 5 main parameters that we calibrate in the model, the values in 2000 and 2010 separately. So what happened over time? So the aggregate distribution share fell from 3.8 to 2.5%. The ratio of the aggregate to average fell from 1.6 to 1.4. And the share of sales across states increased from 23 to 32. And at the same time, also the sales share of the largest 10% of firms increased slightly. So when we plug that into the model, and what we infer is that, well, the productivity of the distribution sector increased, AD increased, epsilon fell. That's because, again, the ratio of aggregate to average fell, and beta fell also. Okay, the fixed costs, we find a decline in the rate at which fixed costs increase with distance. And what we're able to do then is evaluate, well, how big are the welfare gains from these changes? So what we do here is we basically change these 3 parameters from their 2000 to their 2010 value, and we hold all the other parameters constant. And we see, okay, what are the welfare gains from doing that? And what we find in the baseline is that this implies welfare gains of around 41%. That's from changes in all 3 simultaneously. And what's nice about our exercise is we can do it separately for each parameter. So if we do epsilon only, we find welfare gains of 8%. AD, the change in the productivity of the distribution sector, contributed another around 10%. And then changing beta, the decrease in fixed costs, accounts for 17%. Now, if you're able to do also maths kind of on the fly, you might notice that these things don't add up to 41. And that's because we find their complementarities built into the model. So in particular, it's kind of the benefits of improvements in TFP and distribution are higher when distribution costs don't increase as rapidly with distance, with a lower value of epsilon. So I think I'm sort of on time, but just to wrap up, and then happy to discuss more. There were 3 big findings that jumped out from the Indian plant level data. So we saw that distribution costs are large. Large plants spend proportionately more on distribution than smaller ones. And obviously there was a discussion about that. I'm happy to continue that on now. And we find that aggregate distribution costs have declined as a share of sales considerably over time. We find that this implies very large welfare gains. And briefly, in terms of sort of policy implications, our model kind of shows that there are actually these kind of complementarities across different aspects of the distribution sector. And kind of, if you thought about a model in which actually firms are innovating or investing and kind of increasing their size, this size dependence with the distribution share implies that actually reforms which kind of make distribution easier might actually incentivize innovation, because they're going to incentivize firms to invest more in growing. So I'll leave it there. I think I'm on time, and happy to discuss further.
Okay, great. Thank you. Yeah, that's great. So now we'll just open everything up to comments and questions. Just go ahead and unmute and jump in.
So I guess I'm you're not sure that you have the data to do this, but curious as to the link between sort of this decline in the expenditures on the distribution share and what actually is behind this. Is this related to these infrastructure? Can you relate it to these infrastructure investments? And that would kind of like really be an aha moment if we could relate it to something to do with infrastructure, something to do with competition. Sort of relating this to let's say Walmart's contribution to US productivity growth in the 90s, that seems to be something that's internal to Walmart. It's not like there's infrastructure investments in the US, which is enabling Walmart to become more efficient. It's they're leveraging this technology inside of the firm for them idiosyncratically to reduce their sort of distribution costs. And if this is all coming from policy, something that the government does, we have one interpretation, But if this is something about that firms can do for themselves, it's somewhat different.
Yeah, definitely. And by the way, Alessandra, feel free to jump in at this point also, I guess, if we're in kind of more free-form conversation. But there is another view in which, okay, there's this huge amount of heterogeneity in the distribution share, even within plant size, right? And a lot of this is probably this kind of differences in efficiency in how good these plants are at distributing, right? And the kind of more like Walmart story. So I think that's there, but I think that it seemed, at least the way a lot of these costs were measured, and the fact that plants are kind of seem to be kind of spending on them and paying kind of other resellers and distributors for these services, made us think that a lot of this seemed to be happening outside the firm, right, rather than inside the firm. In terms of, can we relate it to specifically to infrastructure things? I mean, there might be ways to look at that. I mean, we could sort of just see whether states with greater infrastructure investment saw greater declines in the distribution share. That might be one thing to look at. But
I think the geography component will be our friend here. That's kind of the main.
I mean, maybe
this
aspect of heterogeneity across firms within a size category is actually something that's interesting to look at. I mean, how big is that heterogeneity relative to the cross-firm size heterogeneity? And, some form of, what are the potential welfare gains from bringing the worst firms within a size category up to the best firms? Is that something, everybody becoming the within class Walmart, what does that do? Maybe building some element of that heterogeneity into the model as well might be interesting to think about.
yeah,
I wanted to make a comment about your general conclusions as regards to larger firms. And my comment is anecdotal. It's not based on literature. It's not based on statistical data. But when I hear what you say about India, I observed a very similar phenomenon in China in the 1990s. I happened to be privy to the decision, choices, infrastructure, investments, cost of distribution from the major players like Chung Kong and Hopewell and Hutchison Whampoa. And what I saw there is consistent with your general conclusions. It's hard to share that.
Great, yeah, thanks for that. Yeah. And I think, I mean, there's, countless papers that have estimated the impact of kind of India's reforms from the 90s into the 2000s, which tend to find that these really mattered quite a bit in general, right? It had quite large effects. So it seems, plausible, at least ex ante, that these things did kind of matter quite a bit.
I missed if you said anything about the product dimension of these plants. I would imagine there's a lot of heterogeneity in the distribution of different types of products.
Yeah, we haven't really explored that in the data. Now we could, right? We have some information on the products these plants are shipping, and we could look at heterogeneity across, the product mix. I guess
at some point, no?
Yeah.
You obviously do not see, you see the overall distribution expenses at the firm level, obviously. But I think we at some point looked at sort of how it varies with the number of products. I have to admit now that was a few years ago, so I don't remember exactly why we stopped it, but it didn't kind of at least jump out at us as something important. Because we had some story in mind where maybe you have sort of core products, and then as you sort of reach these distribution costs, you maybe kind of start producing something else that you can also sell locally. That's the kind of story we had in mind, but it didn't kind of look like at least the data was screaming out at us in terms of that. But we can definitely reopen this box. Yeah.
I mean, related to that, you can, if you know something about the products, something about the value to weight ratio from trade data, it's like, how big and bulky is this stuff? How does that map into the sort of distribution cost? I mean, then maybe that heterogeneity, the within size heterogeneity may just be related, in large part to shipping concrete versus, something lighter.
I mean, it's
Yeah.
all within kind of narrow industries, but there could, of course, still be, these differences in value to weight. Yeah.
Yeah.
Thanks.
So yeah, exactly. Like the you know, what we're looking at in the size relationship, right, is sort of within a 5-digit industry, which is as disaggregated as we can go within a given state, right? So we're trying to compare like two guys that work pretty close to each other, and one of them just is twice the size. How much bigger is their distribution share relative to the other guy? But I think there is a lot of interesting heterogeneity there. I think we just need to figure out also if that would be sort of a relevant, you know, what would that kind of help us by in terms of the model and the analysis that would be helpful.
One question, I was wondering, like, so at least to a first order, how far, if I want to think about the aggregate welfare effects of like the change in AD, how far are we from like a Halton result where the only thing that matters is the share of distribution is like one more sector in value added. So you have like 10%, I think, from one of the tables. Then you have the fixed costs, and then there's non-linearities, obviously. But at least for small shocks, do you know like how different is the elasticity to the one from Halton?
That's a great question. Let me think. I think
so we have this. Well, we don't have distortions. We do have the fixed cost.
So we find that the change in AD alone. So like, I mean, the Halton theorem would really apply to changes in the productivity of the distribution sector, right? Yeah. So the other things it wouldn't work with, and we find 10% gains from the reduction or the improvement in AD, and the value added share of
10%.
The share of sales is 10%. Now I'm trying to think.
So I think locally, like there's nothing, because we don't have, it's not a distorted economy in that sense, right? It's all technology. And there is, of course, the fixed cost business, but you know, I wouldn't like put my money on it, but I would think kind of locally, yes, we would be in Halton. But given the way the fixed costs and the extensive margin is set up, and the fact that it's basically the ontiff between distribution and
so the non-linearities will matter for large shocks.
Exactly, exactly. But I think you're probably right that sort of to a first, like locally to a first order, it's Halton.
But we are looking at large shocks. I think like it's more than a 50% increase in the productivity and distribution over that period. So we are kind of, especially being far away, it's pretty big.
Yeah, I'll sort of second. I mean, the gist of Ariel's comment is to try to figure out where these really big gains come from, right? I mean, in the end, these guys, you're going to basically save almost 4% GDP growth per year over a 10-year period. That's enormous. And then, you know, basically, it looked like the distribution costs were going from 3.8% to 2.5%, right, on average. And so how that sort of, you know, in a lot of models, the direct resource gain comes from the savings in distribution costs, and then how that then magnifies over, I guess, 25 times is something to kind of, and I'm sure I'm missing something with how it goes, but it's really big, and I know it's kind of getting compounded multiple times, but kind of figuring that out, I think would be useful. I don't know if there's like a simple formula. Somebody always has a simple formula, so.
I think we could definitely do that decomposition and make it small. I think a big part of it is just the intermediate share is like 77%, which is huge. So you get a bunch of that compounding. But yeah, we can definitely.
There's a bunch of distribution in that sector as well. You're not measuring the data, but it's there. And if you look at the IO tables, you would get some sense of what those transportation margins are.
Exactly. But we can definitely dig into that.
And I would say that in terms of the decomposition, right, like the fixed costs are 17%, or let's say, you know, roughly half of the 40% is kind of the reduction in fixed costs, which wouldn't fit into any of the kind of the Halton type exercises that you consider, right? So there's already that gap there, and really that's kind of pinned down by the fact that like what we see over this period is it looks like interstate trade really increases a lot. So like loads more flows of goods than we saw in 2000. But no, as Alessandro said, I think that there are definitely ways we can sort of dig into that a bit more and kind of highlight how big this amplification is.
I mean,
So
there's a direct relation to what you guys are doing to a model that doesn't have any fixed costs, right? And in that model, that there's not going to be nearly as much gains. I feel like, and
That's
so
right. Yes,
it'd be
yes,
useful to kind of just really kind of lay it out for us where this amplification comes from. I mean, because that's the whole thing. Like, there's a certain literature that just says, hey, everyone sort of faces the same distribution cost, and we'll all have it ad valorem, right? And you guys want to somehow break it up and discipline it, and so anyhow. Sorry, I interrupted you, Mike. Sorry.
Your intuition is definitely spot on. It is like the fixed cost is playing a huge role here.
Well, sorry, 2 comments about, or go ahead, Ben.
No, I waited towards the end to have the measurement pendentry corner, but as a statistical agency employee, rebates should not be considered part of output. That is a price reduction, and so and certainly does not map into the model you have. That's not a direct cost. That's a reduction in revenue.
That is helpful. Thank you. I might reach out bilaterally if there's more details on how.
Oh, if you want more measurement pendentry, I'm your guy.
Okay, great. Thanks.
So I'm gonna like this kind of follows on George's comment. It's kind of more about the functional forms on the distributional costs and the fixed costs. And I mean, just one kind of mechanical question is, like, you guys kind of talked about correlated distortions and how this kind of looks like that. You know, I guess there's a sense in which you're kind of, that functional form on the variable cost will get something like that, because like high quality firms sell further distances, but then also face higher, their distribution share will be, that's kind of right, like what's going on?
Yes.
But then there's the fixed costs. I guess it's like, you know, it's how much is the functional form doing this versus the data, and maybe that's not like a nice comment, but I was just wondering kind of how
when you're saying this is doing this, what is this?
Like you hardwired it, like the fixed cost varies with distance, but not quality, or not quantity shipped, or you know that distance elasticity is just linear, not non-linear, or what happens if it wasn't? I mean, I guess you kind of showed that when epsilon, I mean, I thought that was important, when epsilon goes to 0 kind of thing. I don't know. I just kind of wondering like what those exactly are.
To like the first order, it's sort of the data telling us what epsilon is how quickly this increases with size, and the data is also telling us the beta, which is how far past the fixed cost includes. I think there's one thing, of course, like, you know, we're splitting the world into like a pure fixed and a pure variable. It's probably somewhere in between. But you are also right that the kind of the part of the functional form we're identifying through the data is like kind of an exponent in one case and sort of a multiplicative thing in the other case. Yeah, I think we can't do it in the same way on the fixed cost, because then again, you pretty quickly get to the point where everyone sells everywhere. But we could try to do that on the distribution cost side.
Yeah, I don't know. I mean, I was just wondering what what exactly, especially because it's the correlated part is I think when you connect with the distortion literature is that, and this is kind of like, you set this up in the model in a way that's kind of naturally getting that amplification. And
so I would say that the correlated part really just comes from like however you kind of have, whether it's like the functional form, I think is less important for that. And that's really identified just from the size relationship, right? So I think the moment we kind of take the stand that that's where the size relationship is coming from, you will get this correlated distortion. And the data is telling us how big it is. And you're absolutely right. It sort of boils down to the epsilon. So had we inferred, you know, had we seen kind of no size relationship, would have inferred an epsilon and 0 and like uncorrelated distortion.
Yeah, okay.
Yeah.
I guess the second one is, so you guys kind of hinted at, do you have geography information in one of those data, like let's do the manufacturing one. Do you know where these guys are, or have a sense about? Yeah, you guys got to do that, man. I don't know, like do that. like somehow figure out that, because the thing is like, if you can connect the causal chain, or at least provide evidence that makes it, like places that look like, even if it's suggestive, I think that just further kind of reinforces. Dorian's asking a much more, I'll say, sophisticated point about, is it Walmart doing it or is it India government do it? And I'm just saying like, well, maybe I'm saying it's probably both, but if you can correlate it with outcomes, that kind of, I think, I don't know, I referee all these papers. So I think like the gold standard for like this misallocation stuff right now is connecting changes in policy with changes in outcomes related to misallocation. So that's kind of my.
Yeah, I mean, we have where the plants are located. So then kind of policies or, you know, heterogeneity across states or districts is something that we can kind of, you know, look at least in the cross section or changes over time.
And then I'm going to send one of my students to NYU to talk with you, Alessandra, about some of the data stuff, because he's interested in some of these things. So be on the watch out.
It's now all publicly available, which is pretty cool.
Yeah, that's okay.
Yeah.
Craig, you want to call it a
Yeah.
wrap? Kim, you're always making the call.
Okay, I